Hello, welcome to Maths is Not a Mystery again. We're going to be solving equations today, algebraic equations with two unknowns, one unknown on each side. Take a look at this first example here. 5x plus 7 equals 2x plus 13. There is no realistic way that you can know what the x can stand for. You can't really work this sort of thing out in your head. You need to have a process and a procedure to help you go through it. So that's what we're going to do today. We're going to learn this procedure and hopefully you'll be able to apply it every time you come across one of these questions. So to get started, the first thing that you need to remember is that this equals sign is a really important thing. The equals sign is a gateway. If something crosses either way over that equals sign, if it goes from left to right or if it goes from right to left, it can only be valid if it changes its sign. So if that 5x were to move over to this side, it would become minus 5x. If that plus 7, because remember the plus sign belongs to the thing behind it, if that plus 7 crosses over there, it has to become minus 7. Same with this, 2x, if it crosses over to here, it's minus 2x. And so on. So whenever something crosses the equal sign, it moves from plus to minus or from minus to plus. So the first job you've got to do when you solve an equation is that you need to be able to get all of the x's, or whatever letter it might be, on one side of the equation, and I'm always going to make it the first side of the equation, and all the numbers on the other side, because ultimately you want your answer to be something like x equals 3. Okay, so the first thing we're going to do is we've got a 5x here and we need to get this 2x to come over onto this side. Now remember what I said about crossing the line. When you cross the equation sign, it's got to be negative. So this is now minus 2x. So what we've got here is 5x minus 2x. Okay, and I'm just going to put in brackets over there, minus 2x. 5x minus 2x is 3x, so that's going to leave us with 3x there. We haven't changed the numbers, so 3x plus 7 equals 13. Okay, the 7 is still there, the 13 is still there, but the 2x has become minus 2x and it's gone over there. So we've got all the x's. There are no x's left over on that side of the equation now, but the numbers are still on two sides, so we now need to shift this 7 over to the other side of the equation. Now that's a plus 7, so if we're going to move it over, it's going to be minus 7. So we're going to keep the 3x that we've created on this side, equals, and this is going to be 13 minus 7. 13 minus 7 is 6. And now it's nice and simple. 3x is 6, well, 3 of them make 6, so divide 6 by 3, a single x must be 2. And that's it. And if we want to just plug it back into the question, 5 2s are 10, plus 7 makes 17. 2 2s are 4, plus 13 makes 17. Both sides add up to 17 if we have x as 2. And so it must be right. Let's do another one. And this time 6x plus 11 equals 3x minus 4. So we need to get all the x's onto the first side of the equation. We've got 6x already there. We need to shift this 3x across to the other side. That means it's going to be minus 3x. 6x minus 3x leaves us with 3x. Leave everything else the same. 3x plus 11 equals minus 4. Okay, we only move one thing at a time. That's important because if you start to move lots of things at any one time and it goes wrong, you can't go back and unpick your problems. If you move one thing at a time, you can go back and find out where you went wrong. Okay, so the x's are dealt with. Now we need to sort out the numbers. So keep the 3x here. 3x equals, we've got to move that plus 11 over to the other side. That means it's going to become minus 11. Minus 4 minus another 11 is minus 15. three x's are minus 15. So 1x divided by 3, 1x must be minus 5. I'm not going to go plugging it back into the question again because that wastes your time, but if we did, we would find out that both sides of that equation balanced. Okay, so always we're bringing things backwards and forwards across the equals line and remembering to swap their signs. Okay, let's take a look at another one now, because there's a slight complication that I'm going to put into here. Now, this looks the same on the surface. 3x plus 6 equals 5x minus 20. But when we start this, I've got a concern that I want to avoid. If we do what I've told you to do so far, and keep the x's on this side, that 5x has to come across the equals sign, become minus 5x. So 3x minus 5x becomes minus 2x. There's nothing wrong with that if you're happy with it, but I don't like it. And I would prefer to always have positive numbers over on this side. So all I'm going to do is I'm going to turn this entire equation round. Now this doesn't involve changing signs at all, because if you look at what I've done now, I've moved that section there, the 3x plus 6, over to that side. And I've moved this section here, the 5x minus 20, over to this side. Think about logically, that adds up to a number, and that adds up to the same number. That's why it says equals in the middle. Well, if we swap them over, it's still the same, isn't it? If that adds up to 10, and that adds up to 10, it's saying 10 equals 10. So if we switch them over, it's still 10 equals 10. We don't have to fiddle around with minuses and pluses there. We're just turning it round, because now 5x, move that 3x over, that becomes a minus 3x. 5x minus 3x is 2x. That's much nicer. Leave everything else the same. 2x minus 20 equals 6. Now we need to move that 20 over to the other side so that the x is left on its own and isolated. To move the minus 20 across the other side of the equals sign, that means it's becoming a plus 20. So 2x equals 6 plus 20, 26. So a single x must be 26 divided by 2, which is 13. Exactly the same there then as the other questions, except that when it becomes inconvenient, when it looks as though it might make it a bit more complicated, switch it round. Because the point about doing maths well is aiming to get it right. Why give yourself an extra complication of having negative numbers where you don't need them? Because there's always a possibility that you might forget them. So avoid it if you can. Now the final question I'm going to do with you looks just the same again, but this one's going to end differently. This one is not going to end with a nice whole number, because examiners don't always give you things that end with a whole number. I think what they try to do is make you worry that if it's not ending with a whole number, you might have done something wrong somewhere. Well, if you know your process well and you're sticking to the process properly, you've got to trust what the numbers say. So let's take a look at it. 20x plus 5 equals 12x minus 9. We want the x's on the first side, and in order to get that 12x to come over onto this side, it needs to become minus 12x. 20x minus 12x is 8x. Leave the rest of it the same. 8x plus 5 equals minus 9. The x's are dealt with. Now we've got to move the numbers. To take that plus 5 over the equals sign, we've got to make it minus 5. So over on this side, 8x equals minus 9 minus another 5. That's going to be minus 14. Now the next step, of course, is that you divide everything by 8. because 8x's make minus 14, so 1x must make, well, a bit more difficult. It actually makes 14 divided by 8. That is going to be the first step of my answer. Except that I'm wrong because it has a minus sign in front of it. That's why I said earlier on, avoid minuses if you ever can. Now, that can be simplified because you can halve both of those numbers. So instead of 14 over 8, we can have it as minus 7 over 4. Okay, and that, of course, can be changed into a mixed number, can't it? Because 7 over 4 is actually the same as 1 3/4 minus 1 3/4. So it can be completed like that. So you've now got a question that ends with a fairly inconvenient kind of number, but we've followed the process correctly. And if you're confident that you've followed it, we've subtracted 12x from the 20x and got the 8x there. We've subtracted 5 from the minus 9 to get the minus 14. Everything else has to be right. So just because there's an awkward number there, it doesn't mean you've done it wrong. So practice that little procedure. Don't ever forget that when something crosses the equals sign, it changes its operation. Plus becomes minus, minus becomes plus. And on the more difficult questions in the video that follows this, divide and multiply switch places as well when we take them across the equals sign. I hope that's been useful, and watch it again. Look at the book that goes with it if you need more help, and good luck with the practice with the solving equations. Thank you for watching. Bye bye.